Okay, guys, today we're looking at simplifying square roots with no fractional radicands, okay? So for the simplest radical form, okay, we've already kind of done the no perfect square factors in the radicand. That was the first lesson we've done. Today we're looking at the no fractional radicand, okay? There should be an R there, but no fractional radicands, okay? So the division property of radicals says if we have the square root of a fraction, we can work with it we want to get that square root out of the denominator. Okay, we don't want any square root to be in the denominator. That's kind of a rule when it comes to radicals. Okay, that's why it's called no fractional radicand. Okay, so if we're looking at this, we don't want a fraction in the radicand. Right? So when we write each number in the simplest radical form, we have the square root of 1/4. What we want to do is we want to break it apart into numerator and denominator. Okay, now we no longer have a fractional radicand. We have two radicals. Okay, one's in the numerator, one's in the denominator. Okay, that's what our property is trying to tell us here. All right, so when we look at that, oops, sorry about that, guys. Okay, when we look at that, what we're looking at here is the square root of 1 over the square root of 4. We can't have, obviously these are perfect squares, so we can simplify them. So the square root of 1 is 1. I think we oftentimes forget about that one. And the square root of 4 is 2. So our actual finished answer here, our simplest radical form, would just be 1/2. Okay, for number 2, I have the square root of 242 over 2. If we look at this, we can actually simplify this 242 over 2. If you see, 242 divided by 2 is just 121. And of course, 121 is a perfect square. So the square root of 121, hopefully we all know, is 11. Okay, so some of these we can kind of break down before we evaluate the square root. Other times we're going to have to break them apart into numerator and denominator like we did the first one. But this one kind of works out pretty nice for us. Okay, if we look at number 3, I have the square root of 3 over 48. The first thing we want to do is we can simplify that. Okay, 3 over 48 reduces to 1/16. Okay, we should be familiar with being able to reduce a fraction and know what that kind of looks like and can reduce down to. If you don't know, you can always just put this into your calculator, 3 over 48, and it's going to give you a decimal. Okay, once you have that decimal, you can hit math, enter, and it'll give you the most reduced fraction form there. Okay, so now the square root of 1 over 16. Again, we can break this into numerator and denominator, so I'd have the square root of 1 over the square root of 16. And of course, these are both perfect squares. The square root of 1 is just 1, and the square root of 16 is 4. Okay, I don't know why these are showing up early over here, but the order must be off on that. Sorry, guys. But the square root of 1 is 1, and the square root of 16 is 4. My final answer would just be 1/4 there. Okay, we're going to do the same process at number 4, as you can see with what showed up already here. Okay, I have the square root of 5 over 60. Of course, I can reduce 5 over 60 to 1/12. So the square root of 1 over 12. Okay. Once I do that, I can break it apart into numerator and denominator like we did over here. The square root of 1 over the square root of 12. The reason we're multiplying this by 3, root 3 over root 3 here, is because look what happens to our denominator when we multiply by root 3. We end up with the square root of 36. Okay, so I have the square root of 3 over the square root of 36. Okay, so when I look at that problem, I would end up with the square root of 3 over 6. Okay, so when we look at this, we know it's a perfect square, so we can simplify. There's a couple different ways you can do that, but this is the way we're looking at for number 4. Okay, moving on to number 5, excuse me. We have the square root of 756 over the square root of 7. Okay, when I look at this, I want to actually combine these ones, because if we look at it close enough, we know that 756 is divided by 7. So for this one, we start with our numerator radical and our denominator radical. We end up using our reverse division property and combining them to 1 to see if we can reduce it, and of course we can. 756 divided by 7 is 108, so I have the square root of 108. I can break that apart. We know how to simplify radicals at this point. Hopefully we know 36 is a perfect square factor that goes into 108. The square root of 36, it's a perfect square, is 6, so I'm left with 6 root 3. Okay, so we kind of have to be able to use that property in both ways and work both ways in order to find the best solution to get to the correct answer with these problems when it comes to the division stuff. Okay, so for number 6, I have the square root of 250 over 2. Again, I start with numerator and denominator, separate radicals. I know 250 is divisible by 2 because it's an even number, so I'm going to recombine them to see if I can't reduce it, and of course I can. I get the square root of 125. Well, hopefully we know that 25 is a perfect square that goes into 125, right? Think of quarters, think of money. Okay, so I get the square root of 25 over 5. Well, the square root of 25 is just 5. So I would have 5 root 5 is my final answer. Okay, so the biggest thing here, guys, is being able to recognize how you can simplify things before you actually evaluate the radical and work with it within the further steps. Okay, so that is it for today. Let us know if you guys have any questions.